Hey everyone, welcome to season 6 of the #Mom Life podcast and episode 117. I'm your host, Cynthia Blaze, and this season we are framing our conversations around hard questions our kids ask and answering them from a biblical perspective. All right, get ready for evolution part 2. On today's episode, I get to ask scientist Dr. Casey Luskin why evolution can't explain the origin of the universe or the origin of life. Okay, get a notepad and pen, people. This conversation is awesome. Today, we're going to dive back into the topic of evolution because I still have questions. I have read that scientifically there are a lot of problems with the theory of evolution and a lot of evidence for intelligent design. I want to ask a scientist to explain some of this evidence, and I'm thrilled today to bring in Dr. Casey Luskin to this show. Okay, so Dr. Casey is a scientist and an attorney with graduate degrees in science and law, giving him expertise in both the scientific and legal dimensions of the debate over evolution. He holds a PhD in geology from the University of Johannesburg. He earned a law degree from the University of San Diego, where he focused on First Amendment law, education law, and environmental law. His BS and MS degrees in earth sciences are from the University of California, San Diego, very close to us right here, where he studied evolution extensively at the graduate and undergraduate levels and conducted geological research at Scripps Institute of Oceanography. Dr. Luskin has been a California licensed attorney since 2005, practicing primarily in the area of evolution education in public schools and defending academic freedom for scientists who face discrimination because of their support for intelligent design. In his current role at the Discovery Institute, Dr. Luskin works as Associate Director of the Center for Science and Culture, where he helps direct the ID 3.0 research program and assists and defends scientists, educators, and students who seek to freely study, research, and teach about the scientific debate over Darwinian evolution and intelligent design. All right, let's meet Casey. Hi, Casey.
Hi, Cynthia. It's great to be on the show with you.
Thanks so much for being here. I have to say that after reading your bio, I love the work you're doing. I'm very excited and impressed by you. And so I'm even more thankful to have you here today.
No, it's great to be on this show with you. I know that you have connections to La Jolla Press, which when I lived in San Diego and went to UCSD for about 5 years, definitely found myself there a couple times and really appreciate, I know it's a great church. So it's great to talk to you today.
Thanks so much. You said you think you even taught here one time in those years.
According to my records, I gave some kind of a presentation there in 2005. Now, that was a long time ago. I don't remember all the details, but according to my notes, it happened. So I guess I did, yeah. But I'll tell you, I wish I lived in San Diego. I mean, San Diego is the best place in the world to live as far as I'm concerned, and I brings back good memories just talking to somebody from San Diego today. I wish I was there right now.
Thank you. We do love living here, and I understand that feeling. This is kind of a funny aside, but when I went to seminary outside of Boston, I worked at a California pizza kitchen because it had the name California in the name, and it made me feel a little closer to California.
Well, moving from San Diego to Seattle was very difficult for me. It took years to adjust.
Yeah.
I'm still not fully adjusted. That was 17 years ago.
Yeah, my brother did 2 years there and promptly clicked his ruby red heels and said there's no place like home and moved back to San Diego. And my husband actually is from Seattle. So we have some connections, but yes, he moved down after college and has never returned. I have to say that Seattle in August and September is one of the most beautiful places in the world.
That is true.
2 months.
The weather over the summer here is just perfect. You cannot beat the weather during the summer. But the rest of the year, it's a little bit rough. Now, my wife loves it here. In fact, she actually prefers Seattle. She also grew up in Southern California, but she prefers Seattle. And so I'm very grateful for that because I'm only here because, this is where I work. Otherwise, I don't know if I'd stay in Seattle. But, my wife, she was made to be in Seattle. So it works out.
All the green trees. I mean, it is beautiful.
The green and the mountains, it all works. Yep.
All right, before we launch into some science questions, I'd love to hear personally, how did you get interested in studying evolution and intelligent design?
Yeah, so that actually story also takes us back to San Diego when I was an undergraduate student at UC San Diego. I remember my very first course that I took my freshman year of college was a course titled History of the Earth and Evolution. And I remember waking up at the, terrible, ungodly hour of 8 a.m. As an 18-year-old knucklehead guy, I did not wake up at 8 a.m. very well. And I ran across the Ravel quad at UCSD and got to my class, right as it was starting. But that was my first class in college, was basically a course in evolution and the history of life on Earth. And I took many courses at UCSD as an undergraduate, and also doing my master's there, I took some graduate courses in evolutionary biology because I was really fascinated by the subject. In fact, looking back, when I look at my transcript, I had almost enough courses in evolution, both at the undergraduate and graduate levels, to have a degree in evolution if only I'd had the foresight to petition for a degree in that subject. At the time, I was just a kid having fun. I was enjoying all these elective courses I was taking in evolutionary biology, and I just wanted to learn as much as I could because the subject of origins just fascinated me. It was like I got the bug. I got sort of just totally into it. Now, at the same time, after my freshman year, at the very end of my freshman year, a buddy of mine, who was another science major, suggested I read this book titled Darwin's Black Box. And that is a book, if some of your listeners may or may not know, but it's a book by Michael Behe, who was a pro-intelligent design biochemist at Lehigh University in Pennsylvania. And this is really one of the main books that kicked off the intelligent design movement in the mid-1990s. This would have been probably in June of 97 that I first bought that book. I had a summer internship that summer in between my freshman and sophomore years, and every day at lunch during the internship, I read Darwin's Black Box. And basically, Michael Behe's argument in that book, and we can probably get into this in more detail, is that there are many complex molecular features in our cells, which he calls irreducibly complex. They are irreducibly complex because they require a certain core set of parts to be able to function and provide any advantage to the organism. And if any of those core parts are missing, then you don't have that function. You don't have any survival advantage. And so it's sort of like an all or nothing game. Either all of the parts are present and the system works, or it's missing one of the parts and it doesn't work. And Behe's argument in his book is that these are irreducibly complex, meaning that you cannot reduce the complexity or they stop working. And this poses a challenge to Darwinian evolution, because Darwinian evolution works where each, little mutation, one little mutation at a time, builds to gives you an advantage essentially. But in an irreducibly complex system, if all the parts are not there, you have no advantage. There is no reason for natural selection to preserve those parts because there's no function to preserve yet. And so he says this poses a challenge to the step-by-step gradual model of Darwinian evolution. And after taking a year of courses my freshman year, I would have sort of these very vague, primitive, rudimentary, freshman year thoughts and I would say, what about like intermediate stages in evolution? Is there a problem there to have these functional intermediates? And it was like Michael Behe put into words what my freshman brain was trying to wrap itself around in all these courses I was taking. And so when I read Darwin's Black Box, I was like, wow, this makes sense. This just it just put all the pieces together for me that I'd been thinking about during my freshman year. And then I started digging into the intelligent design literature. And again, this is sort of in the early days of the intelligent design community. And so there were books coming out, every year or two, there'd be another big book that would come out. So I read books by many of the major folks in the ID community. After Michael Behe, I read William Dembski. I read books by Philip Johnson. I read Jonathan Wells. Then later on, started reading material by Stephen Meyer. And so I kind of just got really into the whole topic. And so I would be taking these classes, on the one hand, learning about evolution, and then on my own free time, I'd be reading books and articles by intelligent design theorists and intelligent design scientists. And I realized that there was this really interesting conversation, even a scientific academic debate to be had over this question of origins. But none of my classes were talking about it. It was essentially completely ignored. Even I would sometimes use the word censored in many of my classes, that it just didn't exist. And so I wanted to learn about the evolutionary viewpoint. I had no problem with that. And I was not the kind of student who would go to my classes, trying to stump the professor or ask the professor the hard question. I just wasn't that kind of guy. I was the kind of student that went to class, listened, took notes. I would ask, questions if I didn't understand something, but I wasn't at all trying to rock the boat. But I was always just a little bit, disturbed that this topic never came up, because my friends and I, we would always discuss this on our own free time. Like, well, how could this system evolve? Or what about, how does intelligent design answer this objection or that objection? And so my junior year at UC San Diego, some friends and I who were, we were various majors, most of us were science majors, we started a student club called the Intelligent Design and Evolution Awareness Club, or IDEA Club for short, to basically give students a forum to have these conversations, because we realized that by and large, our classes were not allowing it. And so the IDEA Club really took off. We were having undergraduates, grad students, we would even invite faculty to come and present to us sometimes. And we made it a really direct point that everybody should feel welcome at the IDEA Club. We didn't hide that, the leadership of the club was largely pro-intelligent design and thought it made sense, but we wanted to make everybody feel comfortable and welcome regardless of what their viewpoint was. And so we got a great group of students who would come to the club. We had atheists, we had Christians, we had Jews, we had Muslims, we had, people of Eastern religious backgrounds, and everything else you could imagine, people coming to the club just to have friendly discussion and dialogue over questions about origins. And so for me, that was really what got me into this, was starting, reading this on my own, taking courses, and then starting this club so students could have their own, dialogues that they couldn't have in their classes. To just cap the story off, when I graduated from UCSD in 2001 with my master's degree in Earth Sciences, the IDEA Club somehow got mentioned in this New York Times story about intelligent design. And so we started getting all these inquiries from all around the country. How can I start a club at my university like what you guys did? And I would say, well, you just start a club and you just invite people, and it's so, sounds so easy. But we realized that a lot of people really didn't know how to do that and sort of the nuts and bolts of intelligent design. So at the end of my, when I graduated from UCSD in 2001, some club members and I and some other folks in the community, we started a nonprofit, the IDEA Center, to help students to start similar IDEA clubs on their own campuses around the country and around the world. And the IDEA Center still exists. And since that time, we've had, some 50 plus IDEA clubs that started at schools around the country. So anyway, that's kind of how I got into it.
That's so cool. I had no knowledge of that. That's really neat that was how you got into it and that you just were passionately wanting information. All right. So I know my questions for you today are really big ones, and books are written about them. My hope is to have you share a few facts that will help really like the everyday mom be able to discuss these topics with her kids or the grandma with her grandkids, intelligently. So, all right. So here are my 3 big questions for you today, and then we'll go through them. So the questions are, what evidence is there that we live in a theistic world, one created by God? What are the problems with Darwinian evolution? And what evidence is there for intelligent design, evidence that life was created and did not evolve by apparently unguided evolutionary mechanisms? Okay, so we're going to tackle these 3 questions one at a time. Now, first, when talking about creation, people use the phrase theistic universe versus naturalistic universe. Can you talk about what those phrases mean first?
Sure. So when we talk about theism or naturalism, we're talking about basically big picture philosophical descriptions of reality and the universe we live in, and also maybe even what's outside the universe. So let's start with naturalism. And if you don't mind, Cynthia, I want to even expand this to more than just theism and naturalism, because there's a lot of different worldviews out there that describe the nature of reality. And I think that we can use evidence from science, evidence from the natural world to help us determine which of these worldviews best explains the evidence. And a lot of this, by the way, is going to borrow from Stephen Meyer's book, Return of the God Hypothesis, which is a great book. If anybody wants a great sort of, I won't say use the word concise, it's not a short book, but it's a great read to really dig into which worldview best explains the best scientific evidence we've discovered over the last, century and few decades. So naturalism, what is naturalism? Well, naturalism is the belief that all that exists is matter and energy. There is no supernatural, there is no God or gods who created the universe, and the universe is essentially self-existing. Now, on the other end of the spectrum is theism. Theism is a belief in a universe that was created by a personal God, a God who is transcendent of the universe, independent of the universe, and created the universe and everything in it, even lives outside the universe. And so, for those of us who are Christians, I don't know if, probably lots of people listen to your podcast, but I'm sure you have many Christian listeners. I personally am a Christian. We would be Christians or, Jews, Christians, Muslims who believe in a personal God who, you can pray to and worship and who answers prayers. They would be theists, okay? We believe in a creator God who made the universe, is independent of the universe, lives outside the universe, and created the universe and everything in it. Now, there's a number of other worldviews that we should touch on really briefly, though, because some of these are actually becoming more and more popular in our society today. For example, there's panspermia, which some people might call space alienism. Okay, that's the idea that, whoever the universe came from, we don't need to really think about those questions. That's too far back. But at the very least, we would say that life and, we were created by aliens who created life and seeded it throughout the universe. And, you may laugh at that, but watch the History Channel. And there's the aliens guy on History Channel, okay? And there's a lot of people out there who actually take this kind of stuff very seriously now. Another, I would say, up-and-coming worldview is pantheism, which is very common among the neo-pagans and sort of this, Wiccanism that is really growing in society today. In this kind of a view, God is essentially equated with the universe, okay? So God is not external to the universe, but God actually is the universe. You and I are all part of God. The trees, the rocks, the rivers, the wind, the stars are all part of God, and that's pantheism. And then finally, there's deism. Deism is a lot like theism in that it does believe that there is a supreme being who created the universe. But the big difference between deism and theism is that in deism, the supreme being sort of created the universe and then just pieced out. He said, "Look, I made everything, but the supreme being doesn't really care about us." And so God basically created the universe and then went off, and it kind of became like the absentee dad kind of thing, and just took off. And although, certainly you'll always encounter people who hold this view. A lot of folks will say, well, I believe that there's something out there, but I don't really know what. I don't know if it's a God you would pray to or worship. A lot of the folks who are in this nuns category of religion, they might believe there's something out there. They see that there's evidence for, it's not just naturalism and materialism. They think there's something that made everything, but they don't put a label on it, and they don't believe that they need to worship it. They don't see any need that's a personal God. So those are sort of, I would say, the 5 different major worldviews. So yes, naturalism and theism are 2 very big worldviews in society today, but there's other ones as well that you'll very commonly find among folks out there. And by the way, I think we can use scientific evidence to discriminate between which of these worldviews is most consistent or best explains the evidence. And I would say that theism actually is the best explanation for consistent explanation for a lot of this. And that's different from getting into intelligent design, but we can talk about the differences there.
That's awesome. I'm taking notes. Okay. All right. So let's go through these 3 big questions, and then feel free, of course, to deviate or add anywhere you want to. But let's start with the idea of a theistic world, of one created by God. What evidence is there that we live in a theistic world?
Sure. So first of all, I would say we have the very fact that there was a Big Bang event. I would equate that with the creation of the universe. And I know that you had William Lane Craig on your show recently. I don't know if you guys talked about sort of the Kalam cosmological argument for the existence of a first cause. But basically it says that anything that begins to exist has a cause. The universe began to exist. Therefore, the universe has a first cause. And the evidence from the Big Bang basically shows that the universe began to exist, okay? And there's some, key lines of evidence which show that the universe started off in sort of this, super condensed state and has been expanding out from that state for about 13 to 14 billion years. Some of the evidence would be the redshift of the galaxies. When we look at galaxies that are very distant from our galaxy, there's a shift in the frequency of light, the light spectrum, to the red end of the light spectrum. And this is because there's sort of like a Doppler effect with light. When a light source is moving towards you, then the frequency is increased, and when the frequency is increased, and when it's moving away from you, then the frequency is decreased. And so it decreases to the red end of the light spectrum. And this is evidence that basically all of the galaxies seem to be moving away from us. And that suggests sort of an expanding universe. this shift in the light frequency to a red spectrum. There's also what we call the cosmic background radiation. This idea that at this, initial explosion of the universe, that there would have been radiation that is left over from this initial explosion that we can detect today. And this is a very specific prediction of the Big Bang model, that if the universe did start off, long ago in this infinitely dense sort of point in time and space, the singularity, and then sort of exploded and expanded outward, that there would be radiation left over from that explosion event. And the cosmic background radiation, not only has it been detected, but it's been detected to very precise frequencies that are predicted by the Big Bang model. So although there's still some, details to be worked out with cosmic evolution models, I think that it's very clear that the universe did have a beginning, and that the galaxies are moving away from each other, that there was a beginning in space and time to the universe. And so that implies that there was a first cause outside the universe, okay? And so, we're talking about basically a super powerful cause that exists outside of space and time and caused the universe to exist. Now, that does not necessarily take us directly to, say, the God of the Bible, but it certainly is very consistent with belief in a creator God. And I would say that actually that evidence alone challenges a naturalistic worldview, because in the naturalistic worldview, all that exists is either, the universe itself or maybe like this multiverse, but there's no explanation for the first cause of that. And theism provides, or you could also say deism, but some belief in an external creator being provides that first cause. So materialism or naturalism and pantheism and what's the other one? Panspermia. I'm sorry. Yeah, pantheism and panspermia, or space alienism. Those three have no ability to account for the initial creation of the universe and sort of an external cause outside of space and time. And so that leaves us with deism or theism. So how can we discriminate between those? Well, when people think of the Big Bang, they often think of think of an explosion. And our experience with explosions is that they are often very chaotic events. You don't expect for order to come out of an explosion. Well, the Big Bang is a different kind of explosion, so to speak, than what we're used to encountering in our everyday lives, okay? You would better to call the Big Bang a very carefully orchestrated and finely tuned expansion event. And it turns out that physicists have discovered that the laws of nature are finely tuned to allow for the universe to basically, for within the universe, for things to form, such as galaxies or stars or planets or complex matter, okay? And this is all because the laws and constants of the universe are finely tuned to allow for these things to form over time. So you have, after the initial Big Bang, you have matter forming, and then that matter begins to condense into galaxies. Within those galaxies, of course, galaxies are composed of stars, so stars are forming, and you can also form planets. And you can look at many of these fine-tuning parameters and the precision, the degree to which you have to have, basically carefully precise fine-tuning of the physical laws and constants is so precise that it implies, I would say, that a great deal of care was taken in the creation of the universe and the crafting of its physical laws and constants. What are some examples of this? Well, if we talk about just the value of the gravitational constant, it has to be fine-tuned within 1 part in 10 to the 35th power. The electromagnetic force versus the force of gravity has to be fine-tuned to within 1 part in 10 to the 40th power. The cosmological constant, which controls the expansion rate of the universe, has to be fine-tuned to within 1 part in 10 to the 90th power. And then it turns out that the vast majority of initial configurations of matter and energy in the universe will not actually yield a universe that has things like galaxies and stars and planets. Either all the matter in the universe is clumped together, and you just get these massive black holes, which are obviously not very conducive for life existing, or the matter is too thinned out, where you can't create galaxies. You can't get interesting interactions between matter and get things like galaxies and stars and planets or life existing. And so to get a universe that has the right degree of clumpiness, as we call it, where the matter is sort of, just right in terms of its clumpiness, you have to have some very finely tuned parameters. The mass density of the universe has to be fine tuned to within 1 part in 10 to the 60th power. The expansion rate of the universe has to be fine tuned in 1 part to the 10 to the 55th power. And then this one kind of just blows all the others away. The initial entropy of the universe, this is sort of the initial disorder in the universe or order in the universe, has to be fine tuned in 1 part in 10 raised to the power of 10 to the 123rd power. Okay, so we don't even have words or names to describe numbers that are that precise or that small. You could try to write that number out, 10 with 10 to the 123rd zeros after it, 1 part in that. And you could be writing that number for the rest of your life, and you would never even get close to finishing it. You would die long before you. I don't have how long it would take. I could come up with some analogy here, but it's impossible. So what this shows basically is that there is an astounding degree of precision and fine tuning that went into the crafting of the physical laws and constants of the universe to allow for our universe to be a place where life could exist, even advanced life, like human beings, like us. And so what this tells me, I think this really challenges a deistic view of the universe, where some, hypothetical supreme being just sort of made the universe and then just took off. I think this shows a creator, frankly, that cares deeply about the universe that he made or it made, and that really, took a lot of care in crafting the universe. And so this is just looking at the evidence for design. I would say this is evidence for intelligent design in physics and cosmology. And just by looking at that, I think we can say that really, if we're talking about just which worldviews, philosophically speaking, are most consistent with the evidence, I would say theism is most consistent. But we can get into more detail when we talk about the biological evidence. I think we're probably going to go there in just a minute, so I won't go there just yet. But the biological evidence for design takes us even more in the direction, I think, of showing that there had to be examples and instances of design in the history of life. And so what that shows is that there's actually intervention by the designer in the history of life to, cause the origin of life to take place, or many of the explosions of new forms of life that we see in the fossil record shows repeated examples of design over the history of life. Well, that is also very inconsistent with deism, because that shows that the designer has been active throughout the history of the universe in terms of, causing certain things to happen. We can get into that in more detail. But I would say, but this is sort of a more philosophical take. We can get into the scientific, argument for design in just a moment. But that's where I would leave it. Yeah, and this shows, by the way, that the evidence for intelligent design does not come just from biology. There's also evidence in physics and cosmology and other fields, even my field of geology. I would say there's evidence for design. But we can get into the biology next if you want. But yeah,
that's fantastic. Okay. Yes, we'll get there in just a sec. Before we get there, let's talk about Darwinian evolution for just a minute, because we're going to get into intelligent design. So let's start with, what are the problems with Darwinian evolution? And maybe even explain what that is, what Darwinian evolution means.
Sure. So, Darwinian evolution is the idea that life has evolved, and it has evolved primarily by the action of natural selection acting upon random variations. Now, that was Darwin's model of evolution. Darwin lived in the 1800s, and obviously at that time, we did not know about DNA. That wasn't Darwin's fault. This is just, science didn't know about it yet. So after the discovery of genes and DNA in the 20th century, there's now an updated version of Darwin's theory called Neo-Darwinian evolution, which takes into account our modern knowledge of DNA and genetics and realizes that the variation that we find among organisms within a population is usually caused by mutations in the DNA. Not always, but usually it's through mutations in the DNA. And so Neo-Darwinian evolution really is, I would say, the reigning paradigm of biological origins today in the field of biology. Of course, there's been a lot of, there's this extended synthesis, there's new ideas, but usually those are viewed as sort of like, Neo-Darwinian evolution is sort of the foundation of how life evolved, and then you've got some more ideas at the top that maybe can be used for certain particular cases. But Neo-Darwinian evolution is still said to be really the reigning paradigm of origins of biology. So what it says is that there are mutations that occur in DNA, and those mutations cause variation within a population of organisms. And that variation says that causes some organisms within a population will become better at surviving and reproducing than others, okay? And there's sort of competition to survive and reproduce. So those organisms that are better able to survive and reproduce, they will tend to do so. And so therefore, a species will evolve in the direction of those organisms, and this is how a species then evolves. And according to Neo-Darwinian evolution, not only do you have species evolving over time, but you can have one species evolving into entirely new forms of life. And so if you trace back the history of life, according to the Neo-Darwinian model, all living organisms should trace back to a universal common ancestor that maybe lived, 3 to 4 billion years ago. We have this universal common ancestor from which all, or maybe, sometimes it's also said to have been a pool of ancestors, but we have this common ancestry of all living organisms. And so that means that not only are you related to all other humans, but you're also related to your pet dog, your pet cat. You're related to the trees that are planted in your front yard. You're related to the fungus that's growing on the bottom of your foot. I mean, not necessarily you, Sensi, but basically all living organisms. I'll confess, I might occasionally have that problem, fungus growing on the bottom of my foot. So I would be, according to Neo-Darwinian thinking, I would be related to that fungus. We're all related, okay? So that is the Neo-Darwinian model. Now, I'm definitely a critic of the Neo-Darwinian model of evolution. That's not to say that it doesn't explain some things. I mean, the mechanism of natural selection certainly is at work in the world around us, and it can explain some things. In fact, we see antibiotic resistance happening before our own eyes. That is a form of Darwinian evolution. You have a person who is sick, there are bacteria inside of them, we give them an antibiotic drug, and it turns out that most of those bacteria will be killed by the drug, but maybe it starts off with just one or two bacteria that have a special mutation that makes them resistant to being killed by that drug. Well, what happens? That's now Darwinian evolution going on. Those those one or two bacteria with that special mutation allowed them to survive the drug, and now they will go on to proliferate and spread and reinfect the person. And that's obviously potentially really dangerous because, okay, the drug didn't work, so now you have to use a new drug to try to target those bacteria. And hopefully you have a drug that can kill off the infection, or the person could actually die. And people who get infected by antibiotic-resistant bacteria, they do die. So this is a real thing. Now, the question is, and this is really one of the key points about Neo-Darwinian evolution, when we see antibiotic-resistant bacteria arising, are these large-scale changes or small-scale changes? What we find is that the kinds of changes that Darwinian mechanisms can produce in living organisms are what we would call small-scale changes, or changes within a species. We don't see large-scale changes like the evolution of fundamentally new body parts or fundamentally new types of organisms or new body plans. Michael Behe, who I mentioned earlier, did a review a number of years ago looking at the types of changes that will occur at the molecular level when we see that Darwinian evolution was in action in a population. What he found is that when we see Darwinian evolution at work at the molecular biochemical level, it tends to actually break things down. So we tend to see, molecular features or proteins or enzymes, they will actually lose their function. And sometimes it might be advantageous for an organism to do that. If you think about it, let's say that you want to have a car that can go faster. Well, it might be advantageous to actually, lose your rear view mirrors, or maybe lose some dead weight you don't need on the car. Now, you're actually losing function in that case, but you're going faster, okay? So same thing with organisms. Sometimes there might be certain environmental situations where it's advantageous to break something or lose a part. But what Michael Behe found is that the vast majority of instances of Darwinian evolution at work actually involve breaking things, not creating new molecular features or new types of functionality. And so again, what we see in Darwinian evolution is, yes, it can do some things, but it's not going to have a creative ability to build fundamentally new types of proteins or body parts or body plans or organisms. And so this is why I would say, yes, it is a real force at work in the world, but it doesn't explain everything.
Good. Okay. So it's an assessment of small changes within organisms okay, good. I got that.
That's right. That's right. And the question is, how far can you take that?
Right.
Can you use small changes? A standard evolutionary biology perspective will be that you can have lots of small changes, and over time, they will add up to big ones. Well, what happens when you have these irreducibly complex features that we talked about earlier? In those cases, if you start off with a small change, there's no function to select for initially. You have to have lots and lots of small changes that lead to a big change. And they have to all be there all at once before you get any advantage to the organism. And that does not work with Darwinian evolution. You have to be able to do each little small change has to give you an advantage. If lots of changes have to be present all at once before you get any advantage in surviving and reproducing, then Darwinian evolution gets stuck and it can't produce those features. And that really is the fundamental problem with Darwinian evolution. There are many features of life that require many mutations to be present all at once. They all have to be there, or the feature won't give you any advantage. And that is where Darwinian evolution doesn't work.
Awesome. Some years ago, actually, my family got to go to the Galapagos, and we got to see the long neck tortoises that he did his original research on. And so that makes sense to see that an animal will adapt to its environment, right? But that's how Darwinian evolution works, is assessing those kinds of things. Or the long neck tortoises survive because they can reach the higher grass or higher bushes, right? But I think what someone once told me is that Darwinian evolution doesn't account for suddenly there's a new flipper that grows, that as you were saying, that those new body parts, those larger changes are not accounted for by Darwinian evolution.
It's a real problem. And this is acknowledged. In fact, there was a major conference at the Royal Society of London a few years ago in 2016 that brought together some leading evolutionary scientists from around the world to talk about the neo-Darwinian synthesis. And one of the opening talks by a leading biologist basically said, look, the problem with neo-Darwinian evolution is we don't have a model for the evolution of novelty, of evolving these new features, and they need a model to account for that. So this is not just intelligent design people talking about this problem within evolutionary biology.
Awesome. All right, so let's get into intelligent design. So first of all, why don't you define what is intelligent design and how does intelligent design interface with evolution? Let's start with those two.
Sure. So intelligent design, sort of the simple definition is, it's a scientific theory which holds that many features of nature are best explained by an intelligent cause rather than an undirected cause like natural selection. And I would say that they're best explained because these natural features have types of information and complexity, which in our experience only comes from an intelligent agent. Okay, so to keep it sort of just at a very basic level right now, in all of our experience, where do things like language and code come from? Well, in all of our experience, whenever we see a language or a code, it always traces back to an intelligent agent or a mind or a personal, basically a personal agent. But yet, what do we see at the very heart of life? Well, we see a language-based code in our DNA that's then processed using sort of computer-like information processing in our cells, where the information in our DNA literally contains commands and codes, which are read and interpreted by molecular machinery in our cells to then produce some kind of an output. And what is that output? Well, the output is protein-based molecular machines. Our cells are literally full of this is mainstream scientists recognize this. Our cells are literally full of molecular machinery which perform all kinds of functions in our cells, okay? So where in our experience, just to keep it very, very basic, where in our experience do things like language-based digital code, computer-like information processing, or machine-like structures, where do these things come from? Well, in all of our experience with the world around us, these things only originate from intelligent sources, from intelligent agents. We have no experience with chance, natural, law-based mechanisms producing these things from scratch. They always trace back to a mind or a personal agent. So this would be part of the argument for intelligent design, that what we see at the very heart of life is a form of information and complexity, which in our experience only comes from an intelligent agent. And we can drill down on that more. There is sort of a concept within intelligent design called complex and specified information. Complex and specified information is the type of information that when we see intelligent agents acting, this is the kind of information that they generate. So what does that mean? I know it's a very jargony term. Well, something is complex if it's unlikely, and it's specified if it matches an independent pattern. Okay, so let's use sort of a real world, a very tangible real world example. Here in Seattle, I live right next to, or not right next to, but we're about 50 miles away from Mount Rainier. I see it all the time when I'm driving around town, at least during these beautiful summers. As you know, Cynthia, we get to see beautiful mountains in the area here. And Mount Rainier, if I've also flown by it many times. A lot of times when you fly out of SeaTac Airport, the pilots will take you right next to Mount Rainier. It's really cool. They do it because they love doing it. They know everybody on the plane loves doing it. But when you see Mount Rainier, you see a shape that really, it's a very unlikely shape. It has some ridges and gullies that are the result of the last time that it went off. I think it was about 600 or something years ago. And it has a very, very unlikely shape. But that shape doesn't match any special pattern. It just looks like a normal mountain. There's nothing about the shape of Mount Rainier that makes me look at it and say, oh, this shape was designed. And I can easily explain the shape of Mount Rainier through normal geological processes like wind and erosion and volcanic explosions and snow and cooling and thawing and all those sorts of things. So when I see the shape of Mount Rainier, I look at it and I say, well, look, there's nothing here that makes me think, anything other than natural processes would produce this. But then I go to another mountain, and the mountain is, of course, Mount Rushmore in South Dakota. And here again, we see a very unlikely shape. It's a very, very unlikely shape that it would have, just like Mount Rainier is an unlikely shape. But in Mount Rushmore, what we see is a shape that matches the faces of 4 famous presidents. So now we have something that is both unlikely or complex, and it's specified, and then it matches an independent pattern. And that complexity plus specification shows us that design took place. And we could use many examples of this. If you're driving down the road and you see a bunch of paint spilled on the ground, you're going to think, okay, you're not even going to think. It just intuitively, you look at it and you see, okay, there's random paint spilled on the ground. It's an unlikely shape, but there's no pattern here. It's not telling me anything. So you're just going to assume that paint fell off some truck and it just splattered, and there was no intelligent, design to the shape of that paint. But then you come to another paint on the road, and it spells the word stop. Okay, you see the letters S-T-O-P. That's paint on the ground, but it matches letters of the English language, which you immediately recognize as an independent pattern. And you know now that those letters were designed. And so not only is that important that you just intuitively made that design inference by seeing that paint on the ground spells out something that you recognize, but it actually saved your life. Because if you didn't stop, let's say you're at a railroad crossing and you see the word stop. Well, now you got to stop, and you don't stop, that could really end very badly. And so we make design inferences all the time in our everyday lives without even realizing it. And we do this typically by recognizing specified and complex information, something that is both unlikely and matches a pattern. And when we do this intuitively, we just recognize design. So what idea theorists have done is we've tried to sort of study, how do we make design inferences? What is the kind of informational patterns and informational properties that symbolize and signify design, that allow us to recognize design? And what we've come up with is this concept of complex and specified information. And it turns out that living organisms are chock full of complex and specified information. I'll just give one example here real quick. Proteins, okay? Proteins are the workhorses of our cells. Of course, RNA is also very important, but proteins do the vast majority of the functional activity in your cells. Enzymes are a form of proteins. We have all kinds of structural proteins. And it turns out that for many proteins, I'm not talking about necessarily every single protein, but for many of the most, I would say, a large proportion of proteins in our cells, the amino acid sequence of those proteins has to be just right in order for those proteins, in order to provide their functions. Proteins are basically long chains of amino acids that fold up into a very particular shape so they can do some important function inside your cells. And ID theorists and other scientists as well have done what we call mutagenesis experiments on proteins, where we mutate the DNA sequence that encodes those proteins. And we ask, how precise does the amino acid sequence of a protein have to be in order for it to perform its function? And so an ID theorist named Douglas Axe, who's now a professor at Biola University, but he's a protein scientist, got his PhD from Caltech. He did research at the University of Cambridge looking at this exact question. How precise do the amino acid sequences of proteins have to be in order for them to perform their function? He looked at a protein or an enzyme in E. coli bacteria called beta-lactamase that's actually involved in helping to provide antibiotic resistance, as fate would have it. And beta-lactamase, what he determined was, and I would say it's a complex protein, but it's not an extraordinarily complex protein. It's a very typical level of complexity in a protein. There are proteins and enzymes that are far more complex in it, but it's not anything that you would look at and say, oh, wow, that's a really special case. It's like a typical level of complexity in a protein, okay? And he found that the likelihood of a random sequence of amino acids yielding a functional enzyme like beta-lactamase is less than 1 in 10 to the 77 sequences would yield a functional enzyme, okay? So what that tells you is that, there's only been 10 to the 40th organisms that have lived over the entire history of life on Earth, even if we include bacteria, okay? So if every single organism that ever lived was granted sort of this ridiculously liberal assumption that they somehow had a random sequence of 150 that encodes 150 new amino acids in hopes of producing an enzyme like this, you would still be short by 10 to the 34th trials, okay, to produce a single functional enzyme like beta-lactamase, which is a very typical level of complexity in an enzyme. So what this tells you is that proteins have a very high level of complex and specified information. We have a very unlikely sequence of amino acids that has to match a specific pattern in order for it to be able to perform its function. And so proteins and the DNA, the information in our DNA that encodes those proteins, is rich in information, in complex and specified information. And it's very difficult for an unguided, blind search mechanism like random mutation and natural selection, which can't look ahead. It can only preserve what it's got right before it. It can't say, I need these 15 mutations to get it right. No, it can do one mutation at a time. But if you can't get it right unless you have all 15 mutations, then you're going to have a problem. It's going to be very, very difficult. If not, you can do the population genetics math and show that, if someone requires, say 15 mutations before you provide an advantage, it cannot arise in the entire history of life. And that's a very modest, modest ask for producing a complex protein like this. I mean, you probably most likely need far more than just that. So we're talking about features that are information rich and inaccessible by a blind search mechanism like Darwinian evolution. And so this is a great example of why we say that intelligent design is the best explanation for many features we see in living organisms. They're rich in information in this language-based code that encodes these CSI, complex and specified information rich proteins. And in our experience, only intelligent agents produce this kind of information. So that's sort of a very nutshell argument for intelligent design. I know that probably was too much there, but there you go.
That was good. I'm going to re-listen to it and then I'll understand it.
Okay, all right, fair enough.
No, that was good. That was really good. So you answered there, talking about what is intelligent design, and then how does intelligent design?
We didn't get to that. Yeah, the great thing about the internet, YouTube, whatever, is you can always rewind and listen. I do it all the time when I'm listening to people. So sorry that I'm too much data dump here. But so how does intelligent design interface with evolution? That's a really important question. So I would say that there are 3 ways that we typically define evolution. One way would be that it simply means change over time. Change in the strict definition would be change in allele frequencies over time within a population of organisms. Or we could just say change within a species. Within human beings, we see that there are different eye colors, different hair colors, different heights, different body sizes, different skin colors. We have all kinds of diversity within the human species. These are all small-scale changes, and intelligent design has no problem with the idea that we can have small-scale changes within a species, and we can call that evolution. We call that microevolution, and it certainly does occur. So another definition of evolution would be common ancestry, the idea that we talked about this earlier, that all living organisms share a common ancestor. So intelligent design actually does not necessarily have a problem with this either. You could have organisms being related, and yet they were designed, okay? So that's not necessarily two incompatible concepts there. But I would say that within the ID community, there are some folks who are skeptical of universal common ancestry, the idea that all living organisms share a common ancestor, and there are some who actually support it. And there's different views. Sort of, it's a healthy discussion that we have within the ID community over questions of common ancestry. The final definition of evolution would be the mechanism of evolution. What is causing all of this change to take place? What is causing the common ancestry to take place? And for that, the typical answer would be natural selection acting upon random mutations. And of course, there are other factors as well. Some folks will cite stochastic factors like genetic drift or neutral evolution as another force. But all of these mechanisms are blind, okay? They happen automatically. There is no intelligent agent that is guiding these mechanisms, random mutation, natural selection, genetic drift, to produce complex biological features according to standard evolutionary biology, okay? So what intelligent design would say is, sure, these are real forces in nature. I mean, natural selection happens, genetic drift happens, and they can explain some things. But there are many, and maybe that would be where we explain some of the small-scale changes within species. But many of the larger scale changes, what we would call many of the macroevolutionary changes, producing new types of organisms, new body plans, even sometimes, in some cases, it might be difficult to produce a new family or a new genus, or even producing certain new types of proteins, new protein families, is not going to happen by this blind and apparently unguided search mechanism of random mutation, natural selection, genetic drift, etc. You're going to need some intelligently guided, some teleological, some purpose-driven process. And so intelligent agents can think with will and forethought and intentionality to find these very, very unlikely configurations of DNA sequences that yield these complex systems. And so intelligent design would definitely be in contradiction with the claim, the definition of evolution, that natural selection, random mutation, genetic drift produced all the complexity of life. That there's more that's needed, that you need an intelligent agent to produce many of these complex features, produce the information that's needed for many of these complex features. So that is sort of how intelligent design interfaces with evolution. It doesn't reject all definitions of evolution, but it is in contradiction with sort of the unguided nature of evolution explaining everything.
Awesome. That makes a lot of sense. All right. So now let's get into what evidence is there that we were made by an intelligent creator and did not evolve by apparently unguided evolutionary mechanisms?
Well, that's a great question. I probably jumped the gun and already answered this one a little bit.
Yeah.
When we're talking about the information in our DNA and the very precise ordering of the nucleotide bases in our DNA that is necessary to produce functional proteins, I think that's a great piece of evidence that we were intelligently designed. That there is you cannot produce that sort of level of complexity, that degree of specificity, that fine-tuning of the nucleotide sequences in our DNA. It's very unlikely to arise by an unguided search mechanism like random mutation and natural selection. Natural selection and random mutation work great if just one mutation can give you an advantage. But when you need many mutations to be present before any advantage is gained, and that would be the case to produce many of the complex proteins we see in our cells, you can't get there. You can't get all those necessary changes all at once through a random blind unguided search process like random mutation, natural selection, okay? So I think that is where intelligent design really shines. But if we talk about, I can give you 5 big lines of evidence for for intelligent design. And this gets into some of the stuff we've already discussed. So number one, we talk about the need for a super powerful first cause that exists outside the universe to create the universe. That's sort of getting back to the Big Bang. I think that's one piece of evidence. Number two, the fine-tuning of the laws and constants of nature, of physics, that is necessary to produce a habitable universe. Number three, I would talk about this vast amount of complex and specified information that we see encoded in a biochemical language in our DNA, which is then processed through a computer-like system of information processing in our cells, where the cellular machinery will read and interpret and execute the commands that are programmed into our DNA to produce these irreducibly complex molecular machines composed of finely tuned proteins. I know that's a mouthful, but all of that specificity, that complex and specified information, it does not arise without intelligent agent. Now, there's a couple other lines of evidence I would cite, and I didn't get into these yet, and I can kind of get into this really quickly. But what we see in the history of life is a repeating pattern where new forms of life will appear abruptly without clear, direct evolutionary precursors. And this has been widely recognized by paleontologists, that we frequently will see new forms of life appearing in what we call explosions. Lots of new types of organisms appearing abruptly without clear, direct evolutionary precursors, what are sometimes called these transitional forms. And what is necessary to build these new forms of life, these new body plans that these new organisms have? Well, it requires new code in our DNA, thousands of tightly coordinated new genes, and amounts of new genetic and even epigenetic information to produce these new body plans. Well, when we see these, sort of explosions in the history of life of new types of organisms, a great example is the Cambrian explosion. This happened about 520 to 530 million years ago. We see most of the major groups of animals called phyla appearing in the fossil record in just what is often called a geological blink of the eye, a 5 to 10 million year period. That we see most of the major body plans of animals arising. Well, to produce these body plans, again, you need new code in our DNA, you need new genes, you need new information basically a mass amount of information has to be infused into the biosphere, into the world of life, to produce this explosion of new types of organisms. And I think this is a great example of a need for intelligent agent to intervene to produce and introduce this information into the biosphere. And then and we see many explosions like this in the history of life. We don't just see an explosion of animal body plans in the Cambrian explosion, but we see an explosion of, if you go later on, you see an explosion of groups of fish, marine organisms. We see explosion of plants. We see a bird explosion. We see a mammal explosion. There's lots of examples of this throughout the history of life where new types of organisms will appear abruptly without clear, direct evolutionary precursors. And I think that's good evidence for intelligent design in the history of life. And then a final example actually goes to the origin of our own species or our own genus Homo. We're the species Homo sapiens. Genus Homo, species sapiens. In Latin, it means wise man. When our genus Homo appears in the fossil record, we see that it appears abruptly, very different from some of the previously existing types of hominids like the Australopithecines. But for me, what really points to, I think, the design of the human species is the fact that we have all of these unique moral, artistic, intellectual, and religious behaviors, which are found in no other species. And these behaviors go far beyond what is required for mere survival and reproduction, okay? So according to evolutionary biology and sort of paleoanthropology, humans evolved in the African savanna about 1 million years ago, okay? So if all that is required is that you pass on your genes on the African savanna 1 million years ago, some hominid, that was running around, not like any of the humans living today, but somehow it evolved the ability to, compose symphonies and build cathedrals and investigate the, complex mechanisms of the universe, to discover relativity, to paint the Sistine Chapel, to engage in all kinds of beautiful religious behaviors that are found throughout the world, worshiping God and building cathedrals and composing, all kinds of beautiful music to praise this creator. None of this is necessary. If all that we drove our evolution was that we had to pass on our genes on the African savanna a million years ago, okay? All these behaviors that we see throughout all human cultures today, it's universal. We all do all these amazing things. It doesn't matter where you look. All human beings that are alive today do all these incredible moral, intellectual, artistic, and religious activities, and none of it is necessary. If all you needed to do was, outrun a lion or, kill a small rodent so you could eat that night or pick fruit off a tree. I'm sorry, it's not. And so we see that it looks like human beings were designed for purposes that far outstrip the mere requirements of survival and reproduction, okay? And so I think that these are 5 lines of evidence that I think are good, very compelling arguments for intelligent design.
Amazing. Okay. I want to ask you a few more quick questions before we conclude. And I know we're kind of getting towards the end of our time, but I want to ask you just quickly, what is the idea of theistic evolution, and what's your take on that?
Sure, great question. And by the way, I know that you probably have lots of Christians listening to this, and so I'm not here to say that if somebody is a theistic evolutionist, they can't be a Christian. I mean, hardly at all. In fact, I know some wonderful Christian people who call themselves theistic evolutionists. And so this is sort of one of those secondary issues as far as, my Christian faith is concerned, that doesn't get to the core of whether somebody is a Christian, but I do think it's an important question. So we can have friendly, reasonable people can disagree over this, I would say. But theistic evolution is the idea, basically, that God used evolutionary mechanisms and only evolutionary mechanisms to create life. There was no sort of direct intervention by God. If you were to go back in time and rewind the tape of the origin of not just, the human species, but all other species back to the origin of life, all you would see would be blind, natural, evolutionary mechanisms going all the way back. You would see no time when you saw anything happening that could not be explained by standard evolutionary mechanisms that evolutionary biologists have uncovered today. That is sort of the official definition of theistic evolution. Now, if you ask a lot of folks out there, do you believe in theistic evolution? If they say, well, yeah, I believe God used evolution to create life. What do you mean by that? You drill down on that for me. What do you mean? Well, I believe that life is so complex that God must have intervened various times in the history of life, maybe causing, some radical mutation to happen. Well, okay, if that's what you believe, you could call yourself a theistic evolutionist, but you're really a proponent of intelligent design, and you didn't realize it. Because you have now invoked an intelligent agent that is intervening to produce information in living organisms, okay? Now, intelligent design does not necessarily identify the designer, especially within biology. Within biology, all we see is information in our DNA. That information is not going to, spell out, made by Yahweh, or made by Allah, or made by Buddha, or made by Yoda, or made by whoever you think the designer is. It's just an informational pattern that indicates design. But if you're a Christian, you believe, or you're a theist of some kind who believes that God is the designer of that and somehow, intervened in the evolution of life to make that information, you actually are a proponent of intelligent design, whether you realize it or not. So I think that a lot, when I talk to what I call, the theistic evolutionist on the street, a lot of the time, they don't realize that their view is actually more an intelligent design view than sort of the strict definition of a theistic evolution view. I mean, we can define these terms however we want, but if you take the standard strict theistic evolution view, that it's sort of been evolutionary mechanisms all the way back, then that would not, you would never say there was a time where you could detect design, because evolutionary mechanisms produced all the information. There's no need to invoke an intelligent agent. And when you see, some of the major theistic evolutionist groups like BioLogos Foundation, there's some very nice people there who I consider friends, but they would say that evolutionary mechanisms can do the job. No detectable instances of design in the history of life. And so that's a different view from what I would say is the intelligent design view.
Now, in theistic evolution, is it the idea that God essentially did the Big Bang, but then let everything go from there?
Yes, they would.
Okay.
So again, I want to speak for everybody. It's a very broad spectrum. So there's different people out there. But I don't want to speak for them, but I would say that I believe that many of my friends, say at the BioLogos group and that sort of camp, so to speak, would say that they do agree that there is fine-tuning and design at the beginning of the universe, and the Big Bang is evidence for a designer. Now, I don't know exactly how far they take the argument. I don't want to speak for them, but they would be more open, I think, to cosmic design than biological design. So it's a great clarification question there. Yeah.
Okay, cool. All right, so.
But I'm so sorry. Let me say. But I would say, look, if we're able to detect design in cosmology, and we can see fine tuning in cosmology, I would ask my friends in that who sort of hold that view. I would say, well, what if we see fine tuning also in biology? Fine tuning that outstrips, what are the creative powers of Darwinian mechanisms? Could we then detect design in biology as well? That's what I would ask.
Great clarification. Okay. Let's say that there's some moms who are like, this is awesome. I'm so thankful for this. I need some more information. Where would you tell someone to go next? For a mom who's looking for information for herself, but maybe also if a mom wants some information that she could also share with her kids as well.
Great question. So if the mom wants information for herself and she's got time to read a thick book, I'm speaking for myself here that I don't have a lot of time to read thick books these days. But Stephen Meyer's book, Return of the God Hypothesis, really is going to cover a lot of the material that we discussed today. Okay. And I think it's a great place to get some of the arguments for design. Now, if you don't have time to read a thick book, you can go to Discovery Institute's YouTube channel. You can go, search for Discovery Institute on YouTube, specifically search for Discovery Institute Center for Science and Culture on YouTube. We have a YouTube channel with some great animations and videos. Some of these are very kid appropriate, especially high school kids. We've got some great animated video series called the Long Story Short series, which explain a lot of these concepts for kids there, as well as some beautiful molecular machine animations that explain how these molecular machines work and why they provide evidence for intelligent design. So that's a great resource, our YouTube channel. You can also go to we have a podcast. It's called ID the Future. You can go to idthefuture.com, and we have regular interviews with scientists and experts on this topic talking about it. And then we have a sort of everyday news article website called evolutionnews.org. That's evolutionnews.org, where you can get regular articles about this topic and lots of arguments and discussions of the evidence for intelligent design. So, there's a lot of great resources out there. If somebody wants to read a shorter book, I co-wrote a textbook for high school or college-aged kids. And I think it'll work fine for high school, maybe even advanced middle school. And the title is Discovering Intelligent Design. And this is a textbook that is appropriate for use in private or home schools. I would not use it in a public school setting, but private or home school use. It's called Discovering Intelligent Design. And that's a great resource. Frankly, moms will get a lot out of it. It's a great synthesis of the arguments. And then, kids can certainly read it as well. And there's a multimedia curriculum. It comes with a DVD and a workbook as well if you want to buy the whole curriculum, Discovering Intelligent Design.
That's awesome. I'm very excited. I'm particularly going to go look at your cartoon videos, and that sounds like a lot of fun.
They're really fun. We have a great animator we work with.
That's awesome. Okay. Personal question. How has all this knowledge influenced your own faith?
Sure. So it is definitely, for me as a Christian, given me confidence that my Christian faith is true. Now, if intelligent design turned out to be proven false, I'm not necessarily going to lose my faith, okay? I've seen, as a Christian, I'm speaking right now as a Christian, right? I've seen God do amazing miracles in my life and the lives of people around me. I know he's real, all right? But it gives me tools to help show other people and the skeptic that God is real, okay? So I can point to them, look, there's this mainstream scientific evidence that mainstream physics agrees with, that there is a big bang, a beginning to the universe, and all this fine tuning. This is well accepted by mainstream scientists. What do you think this implies? Do you think that materialism is a good explanation for this? Or is there some creator that fine tuned all these natural laws? Or you can talk to your skeptical friends and talk to them about the evidence from our DNA. It may not necessarily, take them directly. The evidence for design is not necessarily going to take somebody to Christ on the cross, but it can help them to take them across that great worldview divide of saying, look, there's no evidence for anything other than material causes, but no, there's actually evidence for an intelligent cause being involved in the history of life and the history of the universe. And I think we can help show that that there's good reasons to believe in what we believe. So as a Christian, I think of a verse like 1 Peter 3:16, which says to always be ready to give reasons for the hope that you have, and essentially giving reasons for why we believe what we believe. This is not getting outside of intelligent design. I'm speaking as a Christian now, but you can give reasons for why you believe that there is a mind behind it all from the scientific evidence. And in our very scientifically fluent culture, this is a great way to talk to folks who are skeptics.
That's awesome. All right. Any last thoughts or words of encouragement for moms or dads who are listening as we close?
I really appreciate you having me on. I think this is a great resource for people, and I'm going to refer this to some moms that I know, and,
okay, cool.
And hopefully it gets some more listeners for you. So thank you so much, Cynthia.
Thank you, Dr. Casey. This was such a pleasure to spend this time with you.
It's been a lot of fun. Thank you so much.
Wow. That is exactly what I was looking for when I started this quest to understand evolution. Even though I know I'm going to have to re-listen to parts of this episode a few times before it really sticks in my brain. I'm so thankful for Dr. Casey and other people like him who are using their amazing brains to glorify God in the scientific realm. I hope this episode encourages you all that science supports Scripture. Science supports the belief that a single, independent, spiritual being created the universe and all life as we know it. That being is intimately involved in creation. He didn't just set it in motion and step back. We see a process of great acts of creation in our geological record, culminating in humankind, who the Bible tells us is made in God's image, imbued with his spirit, and given value and purpose. Colossians 1:16-17 says, "By him all things were created, in heaven and earth, visible and invisible, whether thrones or dominions or rulers or authorities, all things were created through him and for him. And he is before all things, and in him all things hold together." Dr. Casey agrees with mainstream scientific thought that the earth is actually very old and humankind has been around for a really long time. Some of you may ask, well, what's up with the whole 6-day creation thing? Well, here's a big word I learned in seminary: anthropomorphic. The idea is God communicates with us in a way that we understand, in language we understand. When God wants to talk about order and time period, he uses an idea we can understand, the concept of a day. So try reading Genesis 1 with this idea in mind. God is communicating in ideas we can understand. The Bible tells us who created and why. God created everything for his glory. Science helps us understand the when and the how. If you ladies find these podcast conversations encouraging and helpful, please subscribe, share them with a friend, and give us a positive review on iTunes or YouTube. You can find out more about today's episode, show notes from our discussion, and listen to past conversations at momlife.ljpress.org. #MomLife is a ministry of La Jolla Presbyterian Church. Today's episode was produced by myself, Jim Sedgwick, and Justin Kent, and I'm your host, Cynthia Blaze. I pray that each of you experience Christ's deep love for you today, surrender to his leading, and find ways to love, bless, and encourage someone else along your journey today.